Good morning, student. Today I am going to discuss some important point in this chapter, that is motion. So we already discussed about the distance, displacement, scalar quantity, vector quantity, velocity, speed and acceleration. So what is velocity? Velocity is the quantity which defines speed with its direction, and the formula of velocity is velocity equals to displacement upon time, and average velocity equals to initial velocity plus final velocity upon 2. Now come to the acceleration. What is acceleration? So change in velocity per unit time is called acceleration. Now see, if the velocity of moving object is changing, its motion is called accelerated motion. The time rate of change of velocity of an object is called acceleration of that object, and acceleration equals to change in velocity upon time interval. Acceleration represented by small a, and change in velocity, here v represent final velocity and u represent initial velocity and t represent time. Let us consider an object having velocity initially 10 km per hour, and after 2 hours it attain 15 km per hour. So how can we find the acceleration? 15 km per hour minus 10 km per hour upon 2 hours. So the acceleration is here 5 and here 2. So the acceleration is 2.5 km per hour square. Okay. So this way we can find the acceleration of any object. The SI unit of acceleration is meter per second square. Now come to the very important point, that is graph representation of motion. Now why we use graph? To describe the motion of an object we can use line graphs. In this case, line graph shows dependence of one physical quantity such as distance and velocity to the other quantity, that is time. Now just see the distance time graph. See, on the x-axis we have time and on the y-axis we have distance. If the motion is uniform, that means the object covered equal distance in equal time interval, then the motion is uniform and we always get a straight line. Okay, we can find the velocity to find the slope of this straight line. I believe in future you will learn to find out the slope of a straight line in your mathematics. Now just see here, distance time graph of an object moving with uniform speed. If speed is uniform, that means velocity is not, speed is not changing, direction is not changing, that means velocity is also not changing. So this kind of motion is called non-accelerated motion. So the speed v of an object therefore can be represented by v equals to s2 minus s1, that is change in displacement upon t2 minus t1. Now this is a star point. Then how can we find the slope of a straight line? Slope of a straight line equals to change in y-axis and change in x-axis. Now you can relate this formula. Change in y-axis is s2 minus s1 and change in x-axis is t2 minus t1. Now come to the distance time graph of a non-uniform motion. If we have non-uniform motion, then we will find this kind of curve, because here the velocity is changing in non-uniform way. Now come to the second graph, that is velocity time graph. So from velocity time graph we can find two physical quantities. Now here we are talking about the first one. The first one, what is the first one? See, you know the formula, velocity equals to displacement upon time. That means displacement equals to velocity into time. So from this graph we can find out the displacement of the object. Now see here, on x-axis we have time and on y-axis we have velocity, and here you can see that velocity is not changing with respect to time. That means this is the velocity time graph for uniform motion. From uniform motion, if there is no change in velocity, that means this is non-accelerated motion. Now, how can we find the displacement? The area enclosed by the velocity time graph and the time axis will be equal to the magnitude of the displacement. Now, we have to find out the area covered by this Okay, so here we have to find out the area of this rectangle. Rectangle का area क्या होता है? Length into breadth. So S equals to AC into CD, area of rectangle. So to find out the displacement, we have to find out the area enclosed by the velocity time graph and the time axis. Now come to here. Now this is the velocity. Here velocity is changing but uniformly. Okay, velocity time graph of an object in uniform acceleration, because the velocity is changing in a uniform way. So here we take 2 points on this straight line. Now just draw line parallel to the y-axis, and here draw 2 lines parallel to the x-axis. Now you can see that this area is covered by the graph. Now this is the form of trapezium. You can apply the area of trapezium directly also, but if you not know the area of trapezium, you can distribute this figure into 2 parts. This is a triangle and this is a rectangle. So area of ACBD equals to DBE equals to area of rectangle plus area of triangle. Area of rectangle is length into breadth, that is AC into BD, plus an area of triangle is 1/2 base into height. Now come to the third graph. In the case of non-uniform acceleration motion, velocity time graph can have any shape. Okay, so now here you can see that the velocity is decreasing. So this graph shows negative acceleration, and negative acceleration is also called retardation. Velocity is decreasing with time and negative acceleration is also called retardation. Now this is the graph of non-uniform acceleration. Okay, now you can define this graph. Let's see, this is A, B, C and D. Here you can say see from O to A, this object is showing positive acceleration. Okay, uniform change in velocity. So this is uniform acceleration, and here you can say this is negative acceleration. Again this is positive acceleration and this is negative acceleration. Okay.